welcome back to some math. Hope you had a great day yesterday, and here's what we're going to do today for your Independent Day. We're going to talk about more scale drawings, and then you guys are going to work on an IXL skill for me to just practice this. And I'll talk about IXL in just a minute. But just to kind of recap, yesterday you guys were supposed to take a quiz for scale copies. So please make sure that you do that if you have not already. You guys can always go to your assignments for the week and look at them and see if you've completed them. Okay? All right. Okay, so today is Wednesday, 8/26, and we are going to look at scale drawings. Oh, there goes my picture. So your supplies that you need for math every day are just a notebook and a pencil. Make sure you have those out as we go through these examples. And then our goal for today, again, is just to talk about scale drawings and explain the scale and use scale drawings to find actual distances. So, let me get to the right screen. Okay, so what we're going to do is we are going to practice some with these scale drawings problems. Remember, we're going to always set them up the same way we set up with scaled copies, but we have to read the problem first and highlight the important information. So, Neil made a scale drawing of a house and its lot. The scale of the drawing was 1 centimeter to 7 meters. If the actual width of the front lawn is 21 meters, how wide is the lawn in the drawing? So let's highlight the important stuff. The scale was 1 centimeter to 7 meters. And then it says the actual width of the front lawn is 21 meters. How wide is the drawing? Okay? So remember, for scale drawings, we're going to write down the units that we're comparing. So we're comparing centimeters and meters. So I'm going to say centimeters and meters. Okay? And I'm going to write down the value that goes with that. It's 1 centimeter and 7 meters. Then I'm going to write down, I'm going to put a check here because I've already written that down. It says the actual width of the lawn is 21 meters. So I know 21 goes on the meters side. And the question is, how wide is the drawing? Well, that's our centimeters, so I don't know. Okay? So that's the first step, setting it up in your columns, making sure you keep units together. Okay? And making sure that your scale stays together. Now I need to find the scale factor. And remember, the scale factor, because this is a scale drawing, is going to be the same for both sets. So 1 times some number equals 7. I know that 7 times 1 equals 7, so I know that my scale factor is 7. Now the question is, what number times 7 gives me 21? Hopefully you know your factors of 21, or if you know multiples of 7, you know that 7 times 3 gives us 21. So our answer here is 3 centimeters. Remember, when you write your answers, you always want to put your number and then the units as well, because we are talking about 2 different units here. All right, so that's a pretty simple one. Now let's do one that has a little bit more involved. Ernest made a scale drawing of a house and its lot. He used the scale 9 inches to 4 feet. If the backyard is 54 inches in the drawing, how wide is the actual yard? So this is very similar to the last one. I pulled these questions from IXL, but I wanted to pull some examples so you would have something to go by as you work. So let's highlight the important things. Ernest made a scale drawing of a house and its lot. Okay, he used the scale 9 inches to 4 feet. That's important. If the backyard is 54 inches in the drawing, how wide is the actual yard? Okay? All right? So now let's write down what we're going to do. We're comparing inches and feet. So I know that my little table is going to be inches and feet. Now I'm going to write down the values that go with that scale. 9 inches, 4 feet. And then the other information that it gives us, it says 54 inches in the drawing. Well, I know the inches go with the 9. And I don't know the actual width of the yard in feet. Okay, so here's what we do next. We wrote down our columns and filled in our information. Now we find our scale factor. Okay, I'm going to show you 2 different ways to solve this problem because we could do an easier way than how we've been doing it. So the way we've been doing this, we said, okay, we know that this is not going to be a whole number because 9 times 1 is 9, so it's going to be less than 1. It's going to be a fraction. So we can use the inverse operation and do 4 divided by 9. Well, I cannot simplify this, so I know that my scale factor would be 4/9, and then I would multiply 54 times 4/9. Well, that's great, but 54 times 4/9, if I multiply that gets really crazy looking, right? I get a really big number on top. So we're going to hang here for just a second. Now, I'm going to redo this over here and show you one thing that we could do. Okay, so on this side, we tried to find the scale factor here, and that's wonderful. That's exactly what we want to do. But when you realize that your scale factor is going to be so big, or such a interesting fraction that when you multiply, you get such a big number, and then you have to divide and do all that, here's another way that you could do this. When we have scale drawings, they are proportional, and we're going to talk about that tomorrow more. When we're talking about proportions, that means that it changes the same amount. Excuse me. So it changes the same amount. So that means, similar to the scale factor here, instead of that, I'm going to change from 9 to 54. So I'm going to see what it changes on the same side. What do I do to 9 to get to 54? I could add, but we're talking about multiplying. We're changing the size of things. I know that 9 times 6 is 54. Okay? Remember, I said proportions mean it changes the same amount. So if I do the same thing here, just like our scale factor, I'm going to do the same thing on the other side. Well, what is 4 times 6? It gives me 24, and that would be 24 feet. So here I did not even find my scale factor. So let's come back over to our other problem. We found our scale factor. We did all this. Now we're going to multiply. I could multiply this, and I could get 216 over 9. And then I could divide 216 divided by 9, and I would get 18, 36, and I'd get 24. I could do it that way. Or I could show you another way. Just like we found the proportion on the right side over here, we're going to do the similar thing, but we're going to do it crossways. So I'm going to look at 54 and 9. I know that 9 times 6 is 54. So I'm going to simplify this before I ever multiply. I'm going to divide 54 by 9 and get 6, and divide 9 by 9 and get 1. So 54 divided by 9, 9 divided by 9, and simplified to 6 and 1. So now I'm going to multiply 6 times 4 and get 24, and 1 times 1 and get 1. So my answer would be 24. Okay? So let's recap this before we move on. Fill in your information in your chart, your table, whatever you want to call it. You can find the scale factor, multiply, and then you can simplify that fraction. Absolutely perfect way to do it. Another way to do it is to fill in your table. And if you realize that this is a really odd fraction and you're going to get such a huge number, then see if you can find a proportion from one set of corresponding sides to another. Okay? So we're going to multiply this way, or you could multiply up. Now, if it asks for the scale factor, you have to do it this way, but it doesn't. It wants the actual width of the yard. Okay? If you need to, rewatch this section and then move on to the next. Okay, So now we're given actual and scale lengths, and we're going to find the scale of the drawing. So Roy measured an office and made a scale drawing. The desk is 2 inches long in the drawing. The actual desk is 6 feet long. What scale did Roy use for the drawing? And it gives us something to go by. So let's highlight the important thing. The desk is 2 inches in the drawing. The actual desk is 6 feet, and we want to know the scale. And it tells us what we're going to use for the scale. Okay, so I know that I'm comparing inches and feet. And let's go ahead and write our scale here. So I know that 1 inch, and I don't know my feet. And then let's fill in what we know. 2 inches in the drawing, so 2 inches in the drawing. Actual is 6 feet. Okay, great. And we want to know what this scale is. So we want to rewrite this scale. So, again, we do it the exact same way we've been doing it. Find the scale factor. I can't use this part, but I can use this. 2 times some number equals 6. 2 times 3 equals 6. So that means that 1 times 3 gives me this value. 1 times 3 is 3. Great job. So now my scale is 1 inch equals 3 feet. Okay? All right. Last one. Same kind of problem, but this time it's not 1 something, it's 4 to something. So Dave drew a scale drawing of a house and its lot. The front patio is 12 millimeters wide in the drawing. The actual patio is 9 meters wide. What is the scale of the drawing? Okay, let's highlight the important things. 12 millimeters in the drawing. Actual patio is 9 meters. What is the scale? And it gives us that scale. Okay, so we're comparing millimeters and meters. I'm going to write down my scale before I do anything else. I have 4 millimeters, some number of meters. And then let's write down 12 millimeters in the drawing. Actual patio is 9 meters. Okay, so let's see what we got. I'm going to find my scale factor now. So 12 times something equals 9. 4 times something equals question mark. Remember, if we know we're going to get a fraction, use the inverse operation. Divide that product by 12. And I can simplify this, divide by 3, and I can get 3/4. So I know that I'm multiplying by 3/4. So here I'm going to say 4 times 3/4, and I get 12/4. Remember, multiplying fractions, we multiply numerators, and we multiply denominators straight across. 12 divided by 4 is 3. So my answer here will be 3 meters. So 4 millimeters equals 3 meters. Okay? Now, let me show you that other way what we were talking about. So I'm going to rewrite this. Now, if I know that I'm going to be finding some odd fraction here, then we can use that proportion method. So I know that this set of corresponding sides is going to be proportional to this set. So I know that I can multiply by the same number to go from 4 to 12 and from the question mark to 9. Let me use a different color for you. So 4 times what number gives me 12? 4 times 3. Some number times 3 is 9. I know that 3 times 3 is 9, so I would get 3 meters as my answer for that scale. So then I would get 4 millimeters equals 3 meters. Whichever way makes sense to you, please use that way. If this does not make sense, then don't use it. But some people may find this easier so that you're not dealing with all these fractions as much, if it works out. So this is not your scale factor. Remember, your scale factor is always going to go from one unit to the other. But this is a proportional unit that we're going to use, okay? So your IXL today, let me just tell you about it. Your login info is your username, the first part of your email, and then it says @LenoreK8, and then the password is your student ID number. For today, or any IXL skill for me this year, your goal to get 100 as a grade is going to be to reach 80% on that skill. Okay, you don't have to get to 100%, you have to reach 80%. So IXL is going to be given on Wednesdays, and they're going to be due by the next Monday. So if they're given tomorrow, by next Monday, the 31st, they're due, okay? And then be sure to work out your problems. Don't just put answers in. I can tell if somebody answers 60 questions in 5 minutes to get their 80%, okay? I can see every single problem. I can see how long you've been working. I can see multiple sessions if you work on it multiple times. So please, 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 this is not to torture you. This is for you to practice, okay? And then if you're having trouble, watch this video again. And then if you still have trouble, email me with any questions, okay, guys? All right, have a great day and get that IXL done.